Hello, ladies and gentlemen. This is Mr. Heeren coming at you wherever you are deciding to work from home or wherever you're deciding to work. So I want to do a couple things. First thing I want to do, I'm going to combine 2.2 and 2.3 kind of all into one video. So I apologize in advance. This video is going to be a little bit long. So if you have to take a break, absolutely take a break. But there's a lot of pieces in here, and I kind of want to do it all in one shot so that you have everything in one place. So unit circle, that's what this is about. Both of these sections are going to concentrate on building the unit circle and then using the unit circle kind of the way it works. Let's kind of take a look at this. So in the unit circle, all right, we always start over here. Okay, this is always our starting point right there. So you're always going to start there. And this would be considered 1, 0. All right, so this is 0, 0. Unit circle literally means that my radius is always going to equal 1 all the way around. All right, so we're going to start here. A counterclockwise rotation, so going this way. So going this way is going to be a positive rotation. Going down is considered a negative rotation. All right, so you see you've got a 30-degree rotation, and then you've got a 150-degree rotation. Okay, so if I went this way, this would be considered a negative 90-degree rotation. Okay, so the big point here is that the radius is going to always equal 1 no matter what. So if we consider this, using the degrees from special right triangles, fill in the degrees on the circle. So here's where you're going to start. Let's start with this. Let's consider that, think way back when in the days of your basic graphing. This was positive, positive. This was, back up, back that one up. This would be negative, positive. This would be negative, negative. This was going to be positive, negative. That all carries over into the unit circle as well. Okay, so if we think about the rotations using special right triangles, so my special right triangles would be 30, 60, 90, and 45, 45, 90. So this is going to be 0 degrees. And as I go around the circle, I just kind of keep going 30. Oops, not 60. 45, 60. This one would be 90 degrees. Then I keep going, so I go another 30 degrees. So that's going to be 120. That's going to be 45 degrees. So that would be 135. And I go 60 degrees, and that's going to be 150. Then when I get to over here, this is going to be 180 degrees. Then from here, I go again, 30, so that makes that 210, 45, so that would be 225. Then I go 60, so 180 and 60 will be 240 degrees. So then straight south or straight down is going to be 270 degrees. So then I kind of follow that pattern all the way around again. So I go another 30 to make that 300. 45 makes that 315. Then I go another 60. So that makes that 330. And then when I get back to the beginning, that's also going to be 360 degrees. Okay, so if you notice, these are all going to be my special right triangles as I go around the circle. If I think about it like this, my 4 kind of anchors are the left, right, top, bottom. Almost kind of like in your in a regular graph, those would be your axes, your x and y axis. Those kind of become my anchors in the unit circle. All right, so I've got that. So this one we talked about a little bit before. You know, we've got 1 radian is equal to whatever my radius is. It's going to be kind of 1 arc length. And then when you work your way around, the entire circle, 360 degrees, ends up being 2 pi. Then with a little bit of math, pi is going to be equivalent to 180. And then we did a whole bunch of variations on that. That was a little bit more towards the end of Unit 1, and then 2.1 was there as well. Okay, so if we fill in the radians, all right, we can do that as well. These are all my different variations. So 0 degrees is still 0 radians. 360 we figured out was 2 pi. So if I jump over here, 180 degrees is going to be just pi. 90 degrees ends up being just pi divided by 2. And then 270, you know, it's between pi and 2 pi. So this one ends up being 3 pi over 2. Okay, so now when I get that idea, I can start kind of filling the blank all the way around. So if I look up here in this quadrant 1, you know, we figured out 30 degrees. If you forgot how to do that, remember that if I'm going degrees to radians, I multiply by pi over 180. Remember, like the degrees cancel out. So 30 times pi over 180 cancels out. That's just going to be pi over 6. So then 45 that cancels out. So that's just going to be pi over 4. So then 60 degrees, well, 30 is double 60. So instead of pi over 6, it's going to be double that. So it'll be 2 pi over 6, which just simplifies to pi over 3. So now, when I keep filling that around, all I do is I kind of take my base and I add that, and I kind of add these as I keep going. Okay, so what I mean when I say that is this. So if I take 120, let me change colors here. 120 times pi over 180. That simplifies to 2 pi over 3. So pi over 3 and so pi over 2 and pi over 6 simplifies to 2 pi over 3. Okay, so 135, this becomes 3 pi over 4. And 150, if I follow that along, you know, that cancels out. 15 over 18 can both be divided by 3. So this is going to be just 5 pi over 6. So now, from here, all I do is kind of keep adding on to pi. So this becomes pi plus pi over 6, so it becomes 7 pi over 6. All right, 225 is going to be pi plus pi over 4. So it's going to take this pi plus the pi over 4 from up here. So it's going to be 5 pi over 4. And then 240 is going to be the pi over 3 plus pi. So this becomes 4 pi over 3. So then, for my final quadrant, I'm going to take 3 pi over 2, and I'm going to keep adding that. All right, if you're not comfortable with that yet, that's fine. So all I want to do is I can kind of keep going with that conversion idea. So if I take 300 times pi over 180. It just becomes a matter of simplifying, like 30 pi over 18. Both those can be divided by 3. Both those actually can be divided by 6. So this becomes 5 pi over 3. Remember, I'm kind of approaching 2/3. I'm approaching 2 pi. So 315 then becomes 5 pi over 4 plus 3 pi over 2 plus another, 3 pi over 2 plus another pi over 4. So, sorry, I'm not doing a very good job explaining this. You know what? Just go with this. Rather than try to be clever and start adding fractions with pi, just go for this. So 315 and 180 can both be divided by 6. So this is going to be 7 pi over 4. And then 330 is actually going to be like 2 pi minus pi over 6. So in doing that, that kind of just becomes 11 pi over 6. All right, so all your angles and then all your radian conversions are all into one area here. So you need to be able to build this, okay? So if you can kind of go around the angles, and then if you can go angles all the way around and then convert all that to radians, you're probably going to be in good shape. So this is the angles of your unit circle. So you start here at 0, you go 30, 45, 60. Your next kind of anchor is 90, 30, 45, 60. Next anchor is 180, 30, 45, 60. Then you're at 270, 30, 45, 60. And then all the variations of radians after that. Okay, so we use a special right triangle. So if you forgot what those ratios are for 30, 60, 90, remember that goes 1, hypotenuse is 2, third side is square root of 3. For 45, 45, 90, that goes 1, 1, square root of 2. But here's the tricky part. The radius has got to be 1. All right? So that means that this and this have to equal 1. So what does that mean? That means that I've got to make this 1. So how do I do that? Well, on the 30, 60, 90, all I have to do is divide by 2. That gets me 1. But then if I have to do that all the way around, so that becomes 1/2, that becomes square root of 3 over 2, my hypotenuse becomes 1. Okay, so see how I did that? All I did was divide it by 2, that gets me 1. For 45, 45, 90, well, if I divide by square root of 2, that gets me 1. But that means so if I divide by square root of 2, I have to divide everything by square root of 2. So therein lies my problem. Now I've got a square root of 2 in the denominator. I can't have that. So this is where I have to do that rationalized thing where I multiply top and bottom by 1, and I get square root of 2 over 2. So instead of 1 over square root of 2, which I can't have, this has got to be square root of 2 over 2, square root of 2 over 2. That's what should go there. All right, so 30, 60, 90 becomes 1/2 square root of 3 over 2 and 1. 45, 45, 90 becomes square root of 2 over 2, square root of 2 over 2, and 1. Remember, all this is because my radius has got to be 1. So that means my hypotenuse in both of these has got to be 1. So we're going to fill in quadrant 1, and then everything else is just going to be a reflection of that. So let's kind of look. All right, so what you're looking at is this. So we've got quadrant 1, and you've got kind of everything that is there. You've got the angle measures, and you got pi over 6. So you got to realize this is a 30, 60, 90 triangle, all right, with a hypotenuse of 1. So it's 30, 60, 90. So what this becomes is this. So 30 degrees is 1 over 2. This length would be square root of 3 over 2. Okay? So now, sorry, let's back up. This one, very simple, 1, comma 0. For pi over 6, you know, what's my x value, what's my y value? So this becomes square root of 3 over 2, 1 over 2. All right? So remember, everything over here is going to be positive and positive. All right? So then pi over 4, if you allow me to kind of draw this triangle, that becomes a 45, 45, 90. 45, 45, 90. To where this is 1. But remember, both of my lengths are square root of 2 over 2 and square root of 2 over 2. And then lastly, my 30-degree angle, my 60-degree angle, is a little bit like the 30-degree angle. It's just flipped. So this is 60. That makes this 30. So that means this is 1/2. This is square root of 3 over 2. So it's going to be 1/2 square root of 3 over 2. Remember, x still goes first, y still goes second. And up here at 90 degrees, I'm going 0 left and right. I'm going 1 up and down. So now I can fill, once I have that built, I can kind of fill in the rest of it just by realizing that these are all going to be reflections of that. All right, so, but remember, over here, this goes negative first, then positive. So if I'm going back and then kind of working up, so this becomes -1, 0. So then 30, this becomes negative square root of 3 over 2. 1/2. So everything kind of anchors back to my horizontal axis. So this becomes 30, this becomes 60, all right? So 30, 60, 90, so this becomes positive 1/2, negative square root of 3 over 2. Okay, so they go across from each other. So for this one, it's going to be 45 from this anchor. So it's going to be negative square root of 2 over 2, square root of 2 over 2. So everything's going to be from my horizontal line. Okay, it's just a matter of going back now and then up. So then here, that 60-degree angle, that makes this 1/2, this square root of 3 over 2, actually negative 1/2. So it's going to be negative 1/2, positive square root of 3 over 2. Down below, it's going to be very, very similar. So if we look down here, everything is going to be negative down here. So if you think about, you know, your regular coordinate plane, everything down here was negative, negative. So again, I'm using kind of my x-axis as my anchor point. So let me go here. So this becomes 30, 60, 90. So it becomes negative square root of 3 over 2 and then negative 1/2. Then the 45, 45, 90 coming down becomes negative square root of 2 over 2, negative square root of 2 over 2. And then this one becomes negative 1/2, negative square root of 3 over 2. Everything kind of anchors to there. Everything kind of anchors back to this x-axis here. Okay? So right there. So now we're in this last quadrant, this quadrant 4. This is where my x is positive and then my y is negative. All right, but it's still going to be the same kind of idea. So this is still a 30, 60, 90 triangle. All right, so 30 out, 60 here. So that makes this 3 square root of 3 over 2. Now this becomes negative 1/2. So that becomes square root of 3 over 2, negative 1/2. This becomes square root of 2 over 2, negative square root of 2 over 2. This becomes 1/2 negative square root of 3 over 2. So if you can build one quadrant, you can build the rest of them just by realizing that everything anchors back to the x-axis. Okay, if I think about it, all of them are just special right triangles going back to the x-axis. That's all I'm looking for. All right, so if you think about it using the hand trick, you know, this is your pinky is the x-axis, your thumb is the y-axis, 30, 45, 60. Build your special right triangles. Realize that this is straight up, this is straight out, and then you're kind of going from there. I'll put the links in the daily tasks slides. I'll put these links in the daily tasks slides, but it'd be well worth your time just to kind of watch and just kind of think about what they're doing, just because I think it comes in really, really handy. All right, so you can fill in the unit circle, or if you have it, it wouldn't be a bad idea to print one off of Schoology or print one off the internet. But you guys need to take a few minutes and fill that in just so you have a nice clean one to have. And it should look like this. All right, so if you notice a couple things, this is a finished product, obviously. So you've got angles all the way around. All right, then if you notice, everything follows kind of the same pattern. All the way around, kind of what we were talking about. So this quadrant, all positive, negative, positive, negative, negative, positive, negative. Okay, so if you want to hit pause for a second, by all means do so, just to at least fill out your unit circle. So that's kind of what we're going to be able to do is that. So now I said we're going to jump into unit 2-3. So when you're talking about the unit circle, you're referring to, how does that work with trig? Well, the idea is that the cosine of your angle, A is just your angle, and then that's going to be your x value, where the sine of A is going to be your y value. So a good idea to remember is going to be the cosine of A, sine of A. So all that means is this. If I'm looking at the unit circle, which you guys should have in your notes or should have on a piece of paper somewhere, and by all means print one out. You don't have to draw it by hand, not till later. So if I look at just something simple like, 60 degrees, which becomes pi over 3 as a radian. So if I wanted to look at that, if you look at your unit circle, how does that go? That goes 1/2 square root of 3 over 2, right? That is what your unit circle should have. So what that means is that the cosine of 60 degrees is just going to be 1/2. And the sine of 60 degrees is going to be square root of 3 over 2. Okay, that is kind of what you're looking at right there. So if we take a look here, you can use your hand if you can to do it quick. If you don't have your unit circle, you can kind of use the hand trick. So I've got 30-degree angle, 30, 60, 90. So that's 1/2. That's going to be square root of 3 over 2, and that's going to be 1. So they want the sine of 30, which is going to be opposite. So that's just going to be 1/2. Cosine of 30, remember, is adjacent, and that is just going to be square root of 3 over 2. Okay, and one way to think about this, you know, if you want to think about it from not from the perspective of the unit circle, not kind of using that, but just think back to a 30, 60, 90 triangle. You know, so you got 1/2 square root of 3 over 2, and then 1, right? Sine means opposite over hypotenuse. So all I've got is 1/2 over 1, which is just 1/2. That's all it is. All right, cosine is adjacent over hypotenuse. So that's the adjacent over the hypotenuse, which is just same thing, square root of 3 over 2 over 1, which is just square root of 3 over 2. All right, so that's kind of a different way to think about it. If you can remember the hand trick and kind of remember where everything goes, then life gets way easier. So it's really important that you kind of be able to do that. So 240, you know, just kind of do a quick in your head, think about where this goes. This becomes 180, kind of going a little bit more to 240. That's a 60-degree angle down here. And down here is in negative land. All right, so it's a 30, 60, 90, so that's 1/2. That's square root of 3 over 2, and that's 1. So the sine is going to be opposite over 1. So the sine is just going to be square root of 3 over 2. Cosine is just going to be 1/2. All right, cosine is always going to be your left and right value because that's always your adjacent side. Always your adjacent side is going to be what the x value is. So that's going to be 60 degrees. So when you look, this is your unit circle, obviously. Pay attention to this. Just focus on sine, cosine, and tangent for right now. The rest will come later. But this is kind of what you're looking at. So if you're looking for the exact value means no decimals. So 2 pi over 3. If you want to start drawing this to help you, by all means. So, oops, that should be plus. The other one should be minus. My bad. So 2 pi over 3. If you're not comfortable with between degrees and radians, you can jump to, you can convert real quick. Boom, boom. 180 over 3 is 60. So that's going to be at 120. So at 120, that is 30 degrees past 90, which makes that a 60, 30, 60 degree. So they want the sine, okay? So it's going to go 1/2 negative square root of 3 over 2, hypotenuse of 1. So they want the sine, so that's opposite. So it's going to be positive square root of 3 over 2. Cosine of 3 over 4. 3 pi over 4 times 180 over pi. pi's cancel out. 180 over 4. 180 divided by 4 becomes 45. 45 times 3 is 135 degrees. So where is that? That is right smack dab in the middle of quadrant 2. And this is a 45 degree triangle. Now, if you remember, my lengths are square root of 2 over 2, square root of 2 over 2, and 1. Okay? But remember, this is negative because of where we're located. So my cosine is going to be the side that's on the x-axis. So my cosine is just going to be square root of 2 over 2. All right? Sine of 3 pi over 2, well, if you check your unit circle, 3 pi over 2 is right here on the y-axis in the negative part. So this is at -1, 0. So they want the sine, so that's just going to be 0. Sorry, blanked on that. That's not -1, 0. That is 0, -1. Duh. Which means that is not 0. That is -1. Wow, my bad. Sorry. So sine is your y value of right there. So that is my y value right there. Cosine of 0, remember that's 1, 0. Cosine means your x value. So that is just going to be 1. That's my answer. Okay, so take a quick minute, then we're going to get going. So, now, obviously the unit circle is not made up of just the points from the special right triangles. There's obviously millions of points on there, but they all satisfy this equation. All right, this is the simplest circle equation that you guys have seen before. Back in geometry, you might have seen the equation of a circle where it goes x minus h squared plus y minus k squared equals 1, where h and k is your center and r is your radius. This would have been r squared. So for here, we're making things simple. We're saying, h and k is 0, 0, and your radius is 1. But now we're going to start figuring out what kind of things you're doing here. So the ordered pair at 30 degrees is this. So that's square root of 3 over 2 and 1/2. So this is your x and this is your y. Let's see this here. Square root of 3 over 2 squared plus 1/2 squared. Let's see, does it equal to 1? Okay, so that's square root of 3 squared, 2 squared, 1 squared, 2 squared. So that becomes 3 over 4 plus 1 over 4. That equals 1. That checks out. Okay, so all I'm doing is literally substituting that in and then kind of going from there. All right, so if I'm going to use this equation and go one step further, I need to pay attention to a couple things here. One, I'm in the fourth quadrant. X is 4/5, find y. So I'm going to use my equation to help me out here. So I've got 4/5 squared plus y squared equals 1. So what does this become? Well, this becomes 16 over 25, 4 squared over 5 squared, plus y squared equals 1. So now, basic algebra, subtract 16 over 25, subtract 16 over 25, that's a 5. Y squared equals 1 minus 16 over 25. So that becomes 25 over 25 minus 16 over 25. That becomes 9 over 25. So now square root everything. So y is going to equal 3/5. There's my answer. 4/5 and 3/5 are going to be it. Now, I've also got to pay attention to, I'm in the fourth quadrant. Fourth quadrant is here, positive, negative. So that means my answer needs to be negative 3/5 because I'm in the fourth quadrant. So here, x squared y squared 1, x squared plus negative 4 over 9 squared equals 1. So that's x squared plus 16 over 81, squared 4, squared 9 equals 1. So that means it's going to be 1 minus 16 over 81. So that becomes 81 over 81 minus 16 over 81, which becomes 65 over 81. So x squared equals that. Square root, square root. I was a little early on this square root, sorry. So that becomes square root of 65 over 9. That's my answer. Now, where am I located? Quadrant 3. Quadrant 3 is over here. Negative, negative. That means that my answer is going to be negative square root of 65 over 9. That's my answer. All right. I'm going to skip this one. So what I'm going to do is I'm going to take a look at 2.2 and 2.3, the assignments here. So if we look at 2.3, let's go. That's a lot of them. Let's just skip these last couple. And then over here, you're looking for exact values of these. Let's cut out every other even one. So let's cut out those. All right, let's cut out those 4. That should be fine on 2.3. And then if we look at 2.2, two, 2.2, you're going to do, I'm going to want you to do all of this. 2.2, I'm going to want you to do all of this just because you need to get in the habit of writing down where everything is. Now on the back side, you don't have to do, you don't have to fill in everything, but you should at least do degrees and radians of your hand here where this is 0 and this is 90 and fill it in from there. But you should still do everything from there. Okay. Don't miss the next Google Meet, especially if you have questions, and I will talk to you later.